my name is Andy Acosta, and today I'm going to talk to you about my senior design project, MyoSign. On average, 3 out of every 1,000 people in the United States are functionally deaf. American Sign Language, or ASL, is the largest used sign language among the deaf population, having many different dialects worldwide. It is estimated that about 500,000 people use American Sign Language in the United States alone. The National Institute on Deafness and Other Communication Disorders defines American Sign Language to be a complete, complex language that employs signs made by moving the hands. So why is American Sign Language important to you? Globalization has allowed millions of people from different countries who speak different languages come and work together. Like any other language, it is important that the hearing and deaf community have some way of easily communicating with one another. Individuals with the ability to hear, more often than not, do not know ASL, making communication with the deaf and hard of hearing that much harder. Just the other day, I was at the Apple store, and the person helping me out was deaf, and I wanted to tell them about my project that I'm working on, but one of the hardest things, ironically, was that I wasn't able to communicate this easily with them. Here we can see that we have translators that can translate a certain word into any language. But what about that for American Sign Language? How can we do that? My project plans to eliminate that boundary. Introducing MyoSign. MyoSign is an American Sign Language interpreter. This product uses a Myo armband to send EMG accelerometer and gyroscope signals to a device listener, which then tries to accurately predict the sign that the user is doing. For those who don't know, EMG stands for electromyography and assesses the electric signals when muscles contract. The Myo armband is a gesture recognition device that has sensors in the inside that reads EMG accelerometer and gyroscope signals. The band is worn on the forearm and comes with clips to make it adjustable. Additionally, the armband comes with a Bluetooth dongle to connect it wirelessly to your computer. The armband comes built in with 5 gestures that it can already recognize. The first one is a closed fist, open hand, wave out, wave in, and finally double tapping the middle finger and thumb. In the case of my project, I had to decide whether or not to use 2 armbands or just one. Each situation has its different advantages and setbacks. Most signs use 2 hands, so initially I thought that wearing 2 armbands would make the most sense. Unfortunately, due to the limitations of the armband developer kit, using 2 armbands limits the user to only using gyroscope and accelerometer data. After doing some testing, I found that using one hand was enough because most signs that use 2 hands mirror each other, meaning that the armbands would report the same or very similar data. The extracted data from the EMG sensors allows the user to differentiate signs a little bit better. So, MyoSign summed up. It allows anyone to sign with the armband on and have it appear on the screen. Here I have an example of the final user interface that displays the word that the user is signing. And now I'll show you a short demo. The MyoSign has 3 major components that allow the program to interpret sign language. The first part is the actual data from the sign. Here we can see that the 3 components include capture, analyze, and predict. The first module is the capture module. In this component, I created a custom device listener for the armband to record data for each sign. I allow the user to be able to name the gesture and tell the program how many times they will perform it. The data is saved to a CSV file, and the file name is the name of the gesture. The data for one sign is usually around 150 to 250 lines of data. To get a good data set, I would perform the same gesture around 15 to 20 times. The number of data rapidly increases the more you train the gesture and the more gestures you add. The second part is the analyze component. In this part, I use the gesture recognition toolkit that is a library by Nick Gillian. In this toolkit, I will be utilizing and modifying the dynamic time warping algorithm, or DTW, to classify temporal gestures. Temporal gestures are gestures that perform the same movements over a variable amount of time, since it's incredibly hard to try and perform the same gesture in the exact same amount of time. Here we have two gestures that are being performed. In the top row, you can see that G is being performed, and in the bottom row, R is being performed. The curves look very similar, but if you look closer, you can see that the time it takes to perform them is variable. So what this algorithm tries to do is tries to match the same pattern in different amount of times. In addition to using the dynamic time warping algorithm, I've provided some pre-processing of my own. The device records gesture movement for every millisecond, meaning that these datasets get very large very quickly. In order to make very large datasets a little smaller, I collapse every 5 columns and average the values. In addition, I've also trimmed the data by removing some outliers at the end and beginning of the recording. In order to make the predicting the gestures easier for the program, I've standardized the ranges for gestures. This range falls from 150 to 200 data points per trained gesture. And finally, the predict component. As you saw in the demo, this is a user interface that allows the user to perform a sign, and it will appear on the screen. One of the things I hope to continue developing with this project is the ability to sign complete sentences. Instead of just having an app to display the current word that is being signed, I wanted this program to emulate a translator. Typically, users will enter a complete sentence into a translator and have the sentence returned to them in the language they want. Like traditional translators, I wanted this program to show full sentences. For this, I created a rest position that indicates a space or rest in the sentence. For my program, the rest position involves putting your hand down next to your side. The ultimate goal of MyoSign is to bridge the gap between the hearing and deaf communities. There are many translators for verbal languages, allowing individuals to translate from English to Spanish and Spanish to pretty much any verbal language you can think of. With the technology and knowledge that we have today, it seems like there really isn't any reason that we don't have any nonverbal translators. Thank you.